Right now on the Lyman front, the ground is telling a quiet story. Crews move in small steps. No cheering, no loud flags, just checklists and hand signs. The signal is simple. We are here. We care. We are watching the line. It means they hold steady, even when drones buzz overhead and jammers hiss on the air. And behind that calm, American engineers are already preparing the next layer of the war. Missiles that won't just fly, but adapt mid-flight. On social media, you see short clips. They are not flashy, but they say a lot. According to people on the ground, the point is steady work, steady strikes, and steady nerves. Here's what most people don't understand about American trained systems more broadly. Their impact isn't just skill, it's structure. For example, ERAM, Extended Range Attack Munition, is a small, smart cruise missile. It's built for a drone-heavy, jamming-heavy war. It follows the same logic as American-style squads around Lyman, tiny, distributed, built to fracture momentum instead of matching it. It's also part of a wider American approach that favors adaptability over brute force. The same approach now driving experimental morphing missile programs inside U.S. Air Force labs. Russia's KAB glide bombs depend on momentum, stacking drops, stacking fear, stacking tempo. But when momentum gets fractured, on a street or on a rail, the entire Russian playbook jams. A rail line they repair in 6 hours turns into a rail line they lose in a day. This week, you can feel the energy build at dawn. Ground crews wheel out ERAMs. Near wooded areas like those outside Dubrova, defenders describe the same rhythm. "It was just drone after drone after drone," one fighter said. He added that the goal was simple: make sure the missile can see even when the sky is noisy. That same challenge, seeing through chaos, is exactly what American researchers are solving with articulated, maneuvering missile noses designed to reorient mid-flight. Morning came, and the target still got hit. People watched the clips on X, Elon Musk's platform, and on other social media. The faces looked young, the voices were firm. It was not a movie. It was a long night, and then a longer day. Drone swarms should break a line. They were supposed to break trench lines around Lyman too, but across the front, they don't, because defenders adapted first. American-style units learned to jam feeds, hide heat, force drones lower, and pick them off in batches. Ukraine learned to jam KAB guidance the same way. One study said Ukraine can disrupt the communications link between Russia's glide bombs and GLONASS satellites, making bombs drift. ERAM was built for the other side of that fight. And while ERAM survives jamming today, the U.S. Air Force is already testing missile systems designed to maneuver even when guidance breaks down entirely. Every bomb that drifts, and every ERAM that arrives, turns the Kremlin's plan into an expensive grind. The top says everything is calm. Russian channels repeat neat maps. They point to arrows and say they moved. But the stress shows in the way they talk. Even Russian-friendly analysts now admit the rear isn't safe. ERAM reaches roughly 150 to 250 plus miles, letting Ukraine hit deep without pushing jets forward. And while Russia burns drones and bombs for tiny gains, American planners are preparing the next escalation. Missiles designed to physically adapt in flight, not just follow a fixed path. According to one Air Force note, ERAM marks a new approach to rapid weapons acquisition, built fast to fill this exact gap.
That speed matters when pressure rises.
First, there is a rush. Then, there is a stall. Russia fires KABs and sends small groups. A Ukrainian planner explained the answer in simple steps. Break down the target set, cut the KAB eyes, hold the air lane, then move the strike one rail junction at a time, not 100 miles. This is the same logic driving U.S. research into missiles that can shift behavior mid-flight, because future battles won't reward rigid trajectories. That's how you drain their tempo and keep your own rhythm. So many units now choose safer, smarter paths. They stack short legal steps. They send eyes first. They mask the flight path. They plan the exit before the entry. Logistics officers will tell you this. A firm strike pattern is not a miracle. It is just good habits, done again and again. The mutant concept, articulated missile noses that physically move during flight, comes from that same habit-driven thinking. Assume disruption, then out-adapt it. And online, the message is steady. People repeat a simple line: show up, be seen, keep it peaceful, and keep it going. To understand why this worries the other side, Look back at the shock in 2022 near Liman. A simple summary from their side admits it. The captured city of Krasny Liman was abandoned during organized rearguard battles. It was not a song in a square. It was an army leaving a key rail line. Since then, both sides have learned. Russia throws more KABs, Ukraine adds more jammers, and the United States moves ahead quietly, testing missiles designed to keep control even when guidance breaks down. The lesson is old. Control space by controlling steps, and control steps by cutting rails. After that, the rules got tighter for the attackers and the suppliers. Chips got watched. Flights got watched. One report put it plainly: Russia continues to obtain US-made microelectronics despite strict export controls. That is not a sign of strength. It is a sign of need. Contrast that with the US approach, investing early in adaptive control systems that reduce dependence on fragile supply chains and perfect conditions. When a war machine relies on outside chips while trying to flood the sky with bombs, it tells a story. It is not a story of advantage, it is a story of strain. People see the videos of glide bombs and think it's just chaos. It's deeper than that. When a system spends energy on workarounds instead of clean production, quality slips. That's why American R&D is focused on missiles that don't assume a clean flight profile. Missiles that can correct themselves physically, not just digitally. Energy that should go to accuracy and protection gets wasted on supply games. That always leaks into the field. And worry leaks into tactics. Rushed assaults, short rotations, loud radios. Good strike teams hear that and act. You wait. You listen. You move when the pattern breaks. One update noted that Russia tried fiber optic drone lines to beat jamming. That's a clever fix, but fixes have gaps. Adaptive weapons are built to exploit exactly those moments, when the workaround fails faster than the next innovation arrives. ERAM looks for those gaps in timing and range, and then slips in low,